Hi everyone, hope you're doing well. Today I'm going to explain you about IP addresses. So, firstly, what is an IP address? So, IP address is a unique number assigned to every system on the internet. So, using IP address, the routers will be able to precisely locate where a host is, and it also helps in routing protocols like distance vector routing or link state routing. So, based on the IP address itself, the router, if a router receives any packet based on IP address in that packet, it will transfer it to the next router. So it will decide what is the next hop, what should be the next router to which this packet has to be forwarded. And there are lots of other usages other than this. An IP address typically looks like this. I think you're able to see this on the screen. Uh, So 192.68.0.15. This is an IP address. This is an example of an IP address. So this is called as dotted decimal notation. I'll explain you about how IP address looks like in a bit. So if you want to know about your IP address, so you can search on your browser. You can type what is my IP. So you can open this website, and here it will show you what is your IPv4 address and IPv6 address. I'll explain you what are these two and what is the difference. And on terminal also you can know your IP address from terminal or from command prompt. You can type ipconfig in Windows and ifconfig on Mac, and you will get something like this. So this is my IP address, IPv4 address 192.68.0.197. Subnet mask and default gateway, I'll explain about this later. So constant about this number. This is an IP. This is my IP address, and this is my private IP address. So even if it is known to anybody on the internet, they can't hack it because it is unique. So this is one private IP address, and people just can't uh, locate me based on this. So uh, yeah, let's uh, understand more about IP addresses. Just a second. Yeah. So as I said, an IP address looks like this. Let me write you. Let me write on the screen. So it will be something like 192.168.0.34, let's say, for example. So this is an IP address, and uh, this is, if you convert this, we represent this in binary in 32 bits. So 32 bits, and we call it as an octet or a byte, and each byte is of 8 bits. So 8 into 4 bytes, first byte, second byte, third byte, and fourth byte. 8 into 4 bytes, which gives us 32 bits. And I think you know 1 byte is 8 bits. And let me write this in binary so that you will get more clarity how an IP address looks like. So 192 can be written as 11 followed by 6 zeros. Dot 68 can be written as 01 32 16 8 4 2 1, and 0 can be expressed in 8 zeros, 1 2 3 4 5 6 7 8, and 34 can be written as yeah. If I represent this IP address in binary, uh, this is how it looks like. This representation, the first representation is dotted decimal representation, and the second one is binary. And let me tell you, like the range of IP addresses, they range from 0.0.0.0 to 255.255.255.255. So this is the range of IP addresses available for us. And so how we came up with, like, let me justify this range. So if you put all zeros in all the four octets, zeros in the first octet, zeros in second and third and fourth, we'll get this 0 dot 0 dot 0 dot 0. And if you put all ones in all the four octets, it will get, you get 255 dot 255 dot 255 255. And each octet varies from 0 to 255. The range, this is the range of each octet. So I'll give you some examples and we can find out whether these are valid IPs or not. And as there are 32 bits and each bit can be either 0 or 1, so we have two possibilities for each bit, and there are 32 bits, so entirely there are 2 per 32 IPs available for us, 2 per 32 IP addresses. And 2 per 32 is somewhere around 4 billion. 4 billion IP addresses are available for us for usage. And I'll give you some IP addresses and we'll try to find out whether it's a valid IP or not. So let's take some 127.0.0.1. So as all the numbers are within the range 0 to 255, all the octets are within the range. This is a valid IP address. And 127.255.300.21, this is not a valid IP address, as this third octet is out of range, out of 0 to 255 range. So I hope you will be able to find whether if a given IP address is valid or not. And the first address written over here, this is also called as loopback address. This is a special kind of IP address, loopback address. So these so the range, all the IP addresses starting with 127, 127.0.0.02, 127.255.255.255. These are used for special purposes, then these are reserved, so these are not allocated to any IP address. These are not allocated to any host on any network. We can't allocate them. And so these are loopback addresses. If you want to check whether your OSI layer or TCP IP, the entire 5 layers are working correctly or not, we'll use this. So mainly it's used for debugging purposes, I could say. So just remember this range, this is for loopback addresses. So if you can go and type on any browser this address and you will get to know what you are getting. So you will just ping to yourself, so you will just send a packet to your own system, so that you will get to know if all the layers are working fine or not. And so this is used in ping command. And yeah, that's it about this IP address. And so as I said, there are totally 2 power 32 IP addresses, and these all IP addresses are divided into different classes from class A to class E. So these are divided into these 5 number of classes: class A, class B, class C, class D, and class E. This is a division. I'll explain you how these are divided. Before that, let me explain you about IPv6. So uh, up to until now we are discussing about IPv4. So what is IP? IP stands for Internet Protocol. So this Internet Protocol is used in network layer in OSI stack, and this is one of the important. This is the main protocol that is mostly widely used, and IPv4 stands for Internet Protocol version 4. So this Internet Protocol version 4 is of 32 bits. So in total there are, as I said, 2 per 32 number of IPs available, so which turns out to be 4 billion. But if you consider the population in the world, it's 8 billion. So, and it is growing in a uh, and it's growing in a huge rate of the population of the world. So IANA has decided that these IP addresses might uh, might not be sufficient in the future, and uh, we might get scarcity of IP addresses. That's why they have introduced IPv6. So even though we have 4 billion IP addresses, we use private IP addressing, um, so that um, multiple devices can get same IP address within the net, but if they are present in different networks. So if my mobile is connected to my home Wi-Fi and your mobile is connected to your home Wi-Fi, then we both can have same private IP address, and that doesn't what we say affect the communication. So because if a packet goes out of our network, it goes with the uh, net IP address of a router, and the router connected to our network, and in that way we'll be able to communicate. I'll explain this scenario with a diagram in the next slide. So IANA is an organization which handles IP addresses. It manages all the IP addresses, and so lately recently we are there are a lot of IoT devices. So initially we just used to have uh, systems connected to internet, my computers. Recently and lately we have mobile phones, and now recently all the uh, electronic devices have started communicating on internet, be it TVs, uh, even ACs, fridges, everything is connected to internet, and we might get scarcity of these IP addresses. That's why IANA has introduced IPv6. So IPv6 is of each IP address in IPv6 is of 128 bits. So in total there are 2 power 128 IPs available in IPv6, which is a very huge number. It's tough to represent, like we don't have any uh, some value to represent like billion or trillion. We don't have any number to represent this, so this is a lot, and I think these IPs will be sufficient until humanity exists, I guess. So these these much amount of IP addresses are available in IPv6, and presently we are using both IPv4 and IPv6 combinedly for communication. So mostly we'll be using IPv4, and sometimes we will use IPv6. So that's not at all relevant for gate, and even IPv6 it's not there for gate, not there for gate. So uh, it was introduced earlier, but then it was removed. So initially only IPv4 was there, and in around 2018 or 19 IPv6 was introduced, and after 2 years it was removed. So even if you see any PYQs on IPv6, you could just ignore them because it's not there in current present grade syllabus, grade 2025 syllabus. And that's it about IPv6. So you don't need to worry anything about this. You just remember that it is of 128 bits. That's it. And it's a lot. There are a lot more IPs available in IPv6 than IPv4. So this like we don't get any scarcity in the near future. And so how communication happens with IP, I'll just explain. Just give a brief about it. So if you consider this as a router, once again, let me do two networks. So if you consider this as one router and this is another router, so this is a router at my home, my router, and let's consider this as a your router, and this is my device connected to my router, my device, and this is your device. Let's assume, and there might be other hosts as well in both the channels, both the communication in both the networks. Now if I want, if my device wants to send a packet to your device, they can't communicate like this. So they don't know about the presence, this my device doesn't know about the presence of your device, and he doesn't know where it is. So what it does is it just, so this can't happen. Let me erase this. Yeah, so my device sends a packet to my router, and my device might have a private IP address 192.168.0.1. So my router keeps track of the outgoing packet, and my device also knows the IP address of your router. So, and the MAC address of your device. So IP address of your router and MAC address of your device. So MAC address is of 48 bits. So I'll just explain it briefly. This is a very deep concept, and I'll make a separate video on this explaining how the communication happens. So with this IP, my device sends a packet to my router, and my router changes the IP to its IP, which is a public IP. So it changes it to public IP, which is unique, across the world, and it will flow through different routers on the internet, and it will reach this router, and this router sees the IP address and sees the MAC address, and based on MAC address, it verifies whether it's its own MAC address or not, and it will get to know it is not its own MAC address, and it identifies the MAC address, that this is the MAC address of this device, and it will just forward the packet. That's what happens. So even though we are using private IP address, and here also if the device is using private IP address, and the same, if these two have the same IP address also, private IP address also, the communication happens very smoothly. That how this is how this happens. And so these 2 port 32 IP addresses are divided into 5 classes, as I said, class A to class E. So uh, I'll just mention 4 octets: first octet, second octet, third octet, and fourth octet. And each octet is of 8 bits, 8, 8, 8, 8, 32 bits in total. So if the first number in first octet is 0, so while representing in binary, and 0 followed by anything, this could be anything, this is don't care, uh, this falls under class A IP address. So actually, these 2 port 32 IP addresses are divided into some networks, and we are not sure how many devices, how many IPs to give to each network. So based on the usage, we need to give it. If a big company wants IP addresses, so their demand will be huge. So if you consider company like Google, Microsoft, or TCS, so they might require some millions of IP addresses, might be 2 port 20, this much amount of IP addresses. And if you consider your home private network, you might just require 40 to 50 IPs at max. Mostly we'll require 10 IPs, but at max, if the house is big, we might require 40 IP addresses. And so we need to formulate a procedure so that these IP addresses are uh, uh, distributed according to the usage and not wasted. So if we just give 2 port 20 IPs to every network, then we don't have that many IPs, and that many networks won't be left. So to avoid all this confusion, we are dividing into different classes. So if a big company asks for uh, a group of addresses, so if a group company asks for some amount of IP addresses, we'll give them class A or class B address. And if it's for private organization, if it's for private home network, we can give them class C IP address. I'll explain you about these classes in a detailed way. So as I said, each uh, the first digit of the class A IP address is 0, and all things we don't care. So the range of class A IP addresses is 0.0.0.02 uh, 127.255.255.255. So we are giving half of the IP addresses to class A. So total there are 2 power, I'll delete this once again. So total there are 2 power 32 IP addresses. In that we are giving half, which is 2 power 31 to class A, and 2 power 31 we are leftover, these are leftover IPs. So If you consider this as a first octet, second, third, fourth, and if it starts with 0, so something, so this is fixed. If you fix this, we have 31 bits remaining, so 2 port 31 IPs are remaining, and all this belong to class A IP address, class A group. So given in class A, um, so the class A range I have explained you 0.0.0.02 and 27.255.254.255, and each I'll draw and explain you. 0 followed by 7 digits, 1 2 3 4 5 6 7 dot this dot this dot this. So even class A is divided into some networks. So class A is entirely divided into 128 networks. So all the first bits of first octet correspond to network ID, including this all correspond to network ID, and remaining 24 bits correspond to host ID. So in total there are 2 power 7 networks, as 0 is fixed, and these 7 bits can be 0 or 1, so there are 2 port 7 networks and 2 power 24 hosts in each network. 2 power 7 networks and 2 power 7 24 hosts in each network. So 2 power 7 is 128 networks, and 2 power 24 is 16 million. So not exactly 16 million, approximately. So 2 power 10 is 1024, so this would precisely be 16 into 1024 into 1024, this much amount of hosts in each network. That's how class A IP addresses are divided. And if you come to class B, so if the first bit is 1, then it's not class A for sure, and the second bit is 0, then it is class B. And if the first bit is 1 and second bit is 1 and third bit is 0, this is class C. And if the first bit is 1, second bit is 1, third bit is 1, fourth bit is 0, this is class D. And if 4 bits are 1s, this is class E. So this is B, this is C, this is D, this is E. So in class B, these two digits are fixed, these two bits are fixed, and we have 30 bits remaining, so there are 2 port 30 networks. So here 6 don't case, and followed by 3 more octets. I'll erase this. I'll explain about these 3 classes also. Yeah, so in class B there are 2 port 30 networks, 2 port 30 IPs available, not networks, IPs. This should be IPs, and this entire part is reserved for network ID, and this entire part is reserved for host ID. So there would be 2 power, if consider these 2 octets, it should be 16 bits, but 2 bits are fixed, so 2 power 14 networks and 2 power 16 hosts in each network. 2 power 16 hosts in each network, in one network. So these 2 power 14, in all these 2 power 14 networks, in each individual network there will be 2 power 16 hosts, and in total there were 2 power 30 IPs available. So 2 power 14 turns out to be 16k, and 2 power 16 turns out to be 64k. Just 64, not 164. 64k. So this much amount of IPs, this much amount of networks, and this much amount of hosts in each network. And I think that's it about class B. Yeah, let's talk about class C. So if first two bits are 1 1 and third bit is 0, this falls under class C. So, and there will be 5 down plates, 1 2 3 4 5, and these are also all down case. So let me tell about the range of class B. Class B range would be, I'll explain about the range of class B and class C combinedly. So first let's complete about class C. So these 5 bits can be anything, either 0 or 1, and uh, entire this we allocated for network ID, and these 8 bits are for host ID. So you'll get to know about network ID and host ID in the later lectures. For now, just stick to this. So 16 8 bits, 8 bits 16 plus 5, 2 power 21 networks would be there, and 2 power 8 hosts in each network. So this much amount of hosts in each network. So this turns out to be 255, 256 to be precise. 256, I mean 0 to 255. And these turns out to be 2 million. So 2 power 20 is million and 2 power 21 is 2 million. And so this is what we used in our home network. So as is the network, uh, the IP address that I've shown in the beginning, 192.168.0.34 or something. I don't remember this last subnet. So this is what we use in home, house, or in small networks. And let me tell you about the range. So first I'll talk about the range of class B. So in class B, first digit is 1 and second digit is 0. These two are fixed. First bit and second bit are fixed. And these 6 bits can be anything, followed by anything in the later bits. So the range is from, so if we consider all as zeros, 1 2 3 4 5 6, and everything else is also 0, all are zeros. So all 30 zeros, 31 zeros including this, and 1 1. So the range will be from 128.0.0.0 to until um, 1 0 is fixed for class B. And if you consider all these 6 bits as 1, so 1 0 1 2 3 4 5 6 dot, and all are also 1, and remaining all the other octets are also 1. So this would be 191 191 dot and 255 dot 255 dot 255. So this is the range from 128.0.0 to 191.255.255. This is the range of IP addresses in class B. So you just need to remember that 1 0, first two digits are fixed, first two bits are fixed, not digits, bits, and remaining bits can vary. They can vary. They can either be 0 or 1. So the least is all can be zeros. All zeros is the least. This is the first number, and the more all ones is the greatest, and all ones. So this is this number. So let us do for class C also. I hope you will be able to do this. So in class C, as I said, the first three digits of x 110, and there are 5 more digits available for us if you consider all as zeros, 1 2 3 4 5. So this number, so the if you convert this into binary, this one stands for 128, this stands for 64. So 128 plus 64 is 192. So this starts for 192 dot, and remaining 3 octet zeros. So we just need to see the first octet. So we don't need to care about the other 3 octets. So based on first octet itself, we can say whether which IP address falls under which category. So from here to 223 dot 255 dot 255 dot 255. This is the range. Let me give you a shortcut on how to calculate IP, how to convert from binary to decimal in an easy way. So this is 223, sorry, not 225. 255, it's 223. So 223 in binary is represented as 110 followed by 1 2 3 4 5 6, not 6, 5 ones. into 3, 1 2 3 4. Okay, so this is 223, this is how 223 is represented. And let me tell you a shortcut on how to convert this into binary. So we just need to read bits, all the bits from left to right, bit by bit. So as soon as we see a bit, we just need to multiply it by 2, and if the bit is 1, we need to add 1 to the result. So as soon as we see the 1, the result is 1, and until after we see 1 1, the result is 3. So first it is 1, and then after seeing next bit, we need to multiply it by 2, which 1 into 2 is 2, and we need to add 1 as the next bit is 1. If the next bit is 0, we don't need to add anything, we just need to multiply and stop. If the next bit is 1, we need to add 1 also after multiplying. So until here it is 3, and until here, if you go up to here, so it is 3 up to here, and now 3 into 2 6. Now we don't need to add anything, and until here it is 6 into 2 12 plus 1 13, and 13 into 2 26 plus 1 27, and here 55, and 55 into 2 110 plus 1 111, and triple 1 into 2 222 plus 1 is 223. Let me give you another example in new slide. Yeah, let's give something random, 100 10 10 110. So let's try to convert this into binary, this into decimal. So 1 and 2 4 8 plus 1 9 18, 18 into 2 36 plus 1 37, 37 into 2, I think it's 74, 74 into 2 148 plus 1 149, 149 into 2. So until here it's 149, and here 149 into 2 is 298 plus 1 299, and 299 into 2 is 598. So this number is 598 in decimal. So this is a easy way to convert any this binary number to decimal. Just remember this. And let's talk about class D. So class A IP addresses are multicast address. So these are also not assigned to any what we say, any host. So these are multicast addresses. So uh, if uh, if somebody wants to cast onto multiple device using IP, then we use this. So this is not that much relevant for get. So just remember that it's multicast addresses, and its range is from, so the first 3 digits are 1, 3 bits are 1, and the fourth bit is 0, and we know these are all tone cache. So the range would be from 224.0.0.0 to 239.255.255.255. This is class D. So this is used for multi-classed addresses. So by multi-classed, I mean so we just group some IP addresses into one as one single unit. So we just assign some range of IP addresses for this, and we just send whatever we want to multicast, whatever we want to communicate with this. So it is not so much relevant, that's why I'm not explaining, and I'm also unable to explain this. And let's me explain about class E. So in class E, first 4 digits are 1 fixed, these are all are ones, and remaining all are don't care. So the range is from 240.0.0.0. You can figure this number by putting all zeros over here, by putting all zeros over here, it turns out to be 240, and if you put all ones over here, it would be 255.255.255.255. So this is the range of IP addresses in class E, and we don't have any host or a network ID part in class E and class E. Class E is reserved, so these are reserved. So these are used for testing purposes. If they want to test anything for IP address, they'll use these class E addresses. And we have one more notation called as CIDR notation, classless inter-domain routing. I'll explain it in the next video. For now, just get clarity on this, what are different classes available, and these are from A to E, and these are the ranges. So a total of 2 power, so as 4 bits are reserved. So we have 2.28 IPs available in this, and it's similarly in this 2.28 IPs available in even class E also. So class E is reserved and class D is multicast. And that's it about these classes. There's a popular diagram on the internet, um, which you can use to remember the division of these IPs. I'll just draw it. Yeah. So in total there are 2.32 IPs. So if we consider this first half, so this entire this right side, one second, I'll explain. This entire this right side as one half, and this as another half. So everything starting with 0 falls under this half, and everything starting with 1, let's assume, falls under this half. So let us consider these all the whole IPs available. So this entire circle represents the whole IPs available, which is 2.32. So this half represents class A, as all the IP starting with the first bit as 0 falls under this. So there would be 2 power 31 IPs, and this is class A, and 2 power 31 more will be left. So 2 power 31 class A plus 2 power 31 left over, which is combinedly B plus C plus D plus E, which turns out to be 2 power 32. So don't get confused over here. 2 power 31 plus 2 power 31 is 2 power 32, and these are the remaining B, C, D, E. So among these 2 power 31, again we are dividing this into two divisions. So this line represents this line represents uh, above this. So just consider this half, forget about this. This is class A and this is done. Just consider this second half, and in the second half this line let's suppose this line divides the whole IP addresses into two halves. So the above this entire thing is 2 power 30, and the below is 2 power 30. So this is 2 power 30 and this is B. So if it starts with 0 followed by anything, this is A. If it starts with 1 0 followed by anything, this is B. And now this is 2 power 30, and this remaining would be 2 power 30, and let's assume this line divides this into two halves, and so this would be 2 power 29 and the remaining would be 2 power 29. So this 2 power 29 corresponds to class C, and class C start will start with 110 followed by anything. This comes under class C, and the remaining 2 power 29 are divided into two halves, 2 power 28 and 2 power 28, which this is D and this is E. So D starts with 1110 and E starts with 1111. This is D, this is E. That's how these all 2 power 32 IP addresses are divided. So if we add all this, so just if you want, you can take screenshot of this slide and deleting it. So if I add all this 2 power 28 plus 2 power 28 plus 2 power 29 plus 2 power 30 plus 2 power 31. We'll get 2 power 32. So 2 power 28 plus 2 power 28, these two corresponds to 2 and D. If we add this, we'll get 2 power 29. And if we add this 2 power 29 with this 2 power 29, which corresponds to class C, we'll get 2 power 30. And if we add this 2 power 30 with this 2 power 30, which corresponds to class B, we'll get 2 power 31. And 2 power 31 plus class A 2 power 31 is 2 power 32. And also remember the ranges. I'll draw that also. I'll try to draw that, the ranges of all the IP addresses. If you are if you understood, you can just skip this part and you can end the video, or else if you want to listen, you can just stick to the video. I'll draw it. Yeah, so A, B, C, D, E, these are the classes of IP addresses, the whole 2 port 32. So the class A range is from 0.0.0.0.02 to 127.255.255.255. So first bit is fixed as 1 and all the remaining bits we can change. So if you fix first bit as 1 and all the remaining bits, if you could change, you will get this range. And the second range is from 128.0.0.0 to 191 dot same 255.255. This is class B range, and the class C range starts from 192.0.0.0.02 223.255.255.255. This is class B. Class C. And class D and class E ranges I will write here. D is from 224.0.0.0 to 239.255. This is the range. And class E, it starts from 240.0.0.0 to 255.255.255.255. Actually we need to include until 240.54 only, or else you can also include 255, because this is called as broadcast address, direct broadcast address, direct or limited, I'm not sure what is it is, I forgot. So this is a broadcast address. If we want to, so let me tell you, so you can take screenshot of this if you want. So if you consider this as a router and this as various hosts in the network, and let us assume this host, this is the host, this host wants to send a data packet to all the other hosts present in the same network. In that case, it will just set the destination IP address as this 255.255.255.255. So it will just set the destination address as this, and it will send the data packet. So whatever the information that might contain. So the source IP address will be the IP address of this, and it will set the destination IP address as this, and it will send the packet. So the packet would be distributed to, if a router sees this, the router will distribute to all the packets within the same network. For this purpose, this IP address is used. So we can also call it as reserved. It's not that much required. Yeah, that's it about IP addresses. So if you like my content, you can just comment and share, and I'll try to upload more and more videos about computer networks. So computer networks for gate, I'll try to upload the entire syllabus required, which is required for gate, entire computer network syllabus which is required for gate. Thank you, bye bye.